Hello, this is John from caveofprogramming.com. In this video we're going to take a look at anonymous functions in Kotlin. Specifically we'll look at assigning anonymous functions to variables, passing anonymous functions to functions, and returning anonymous functions from functions. Let's create a variable here of a function type. I'll call this add. Let's make it a variable that can refer to a function that accepts two integers and returns an integer. So for example, we could set that equal to, and now we're going to use anonymous function syntax. So we're going to write a fun keyword. We'll specify the parameters here. Let's have x of type int and y of type int, and that's going to return an int. And we could implement that, for example, with expression syntax if we just do equals x plus y. So this looks a bit funny because here I've got two equals. I could have just used braces and a return statement to implement this function. But if we're only going to do x plus y, I might as well just use a single expression. So we've created a variable which can refer to a function that accepts two ints and returns an int. And then I've created an anonymous function, a function that doesn't have a name, which does just add two integers together that are passed to it. So there's not much point to creating an anonymous function unless you're going to do something with it, like set a variable to refer to it, or pass it to a function or something like that. Otherwise you wouldn't be able to refer to it again. In this case we can refer to it with this variable. So I could say, for example, val result equals add, and we can treat add exactly like a function in itself. Let's add 8 and 9, and then we'll print the result. When I run this, we get the value 17 as you'd expect. Now in fact this whole declaration doesn't have to be quite this complicated because Kotlin can infer a lot of these types. So for example, we could miss off this entire thing here. Let's first make a copy of it because I want to create another function called subtract. So if we miss off the entire type of this variable, Kotlin can infer it from the type of the function. On the other hand, what if we declare the type of the variable but delete some of the types in this function declaration? Kotlin can infer that x is an int from the fact that we're setting this variable equal to this anonymous function, and the variable expects a function that accepts a couple of ints. So we could remove these. And in both of these cases, Kotlin can infer the return type from the types of things that are being returned. So we could actually miss these off if we want. Let's just remove this one. So in either cases, we can end up with relatively brief declarations here. Now it's possible to pass a function to a function, and let's take a look at an example of doing that with an anonymous function like these. So I'll create a function down here which I'll call runOp. Let's say that runOp returns an int, and to obtain that int it's going to add together two integers, so we'll have an x here and a y here, or for that matter it might subtract the two integers or multiply them or whatever. And I want to pass in the function that we're going to use to combine x and y here. So here we need a variable which I'll call op, and the type of that will be a function which accepts two parameters, both of type int, and returns a parameter of type int. So this is the final declaration of our function. It has three parameters, it's got x and y of type int, and it's got op, which is a variable with a function type that can refer to a function that accepts two ints and returns an int. Now within the function body, let's just return the result of doing op on these two arguments. How can we use this function? Let's create a print line here. And actually I think I'll reuse result here, so let's change that to a var. And then just above where we're going to do the print, we can write result equals run op, and we can pass in a function of the correct type. So with the correct signature, the correct parameters and return type, let's pass in subtract, and we'll pass in 2 and 3. Then we'll print the result. And actually I intended to make this minus, because after all I've called it subtract. So 2 minus 3 is -1, so we should expect a result of -1 when we run it. And there we have it. We could even directly pass a function right here to run up that we've actually invented here. So let's just copy all this stuff, paste this in again, and here I'll have maybe 3 and 6. And right here I'm going to define a function. Let's write fun That's going to accept two parameters, let's call them x and y, and it's going to return an int. And we'll set that equal to x times y. In fact, Kotlin can also here infer the return type from the types of these variables. So let's get rid of that. How does it infer the types of x and y here? Because I haven't specified the types of those either. Well, it can infer those from the fact that we're passing it to the runUp function, which expects a function that conforms to certain specifications here. If I run this, we get 18. Finally, let's take a look at an example of returning a function from a function. So here I'll create a function called getOp, and the return type of that is going to be a function type. So I want to return, in this case, a function that accepts two parameters of type int and returns an int. And then we can implement the function. I haven't actually got a function available in this scope that I can refer to. I haven't got a ready-made one. Let's just make one up here. So I'll do return fun. That's going to accept x and y, and it can return x divided by y, for example. Since these are both integers, and I haven't changed either to a float, this is going to do integer division. Let's run this function and get the return type of it. So I'll say val op equals get op. Result equals op, and we'll apply this to maybe 11 and 5, and then we'll print the result. So if I run this, we would expect that we'll get the result 2 because we're doing integer division here. And this has got as a function that just does division in this case. So let's run it, and we get 2. Of course, if I had declared add, for example, or subtract at a different scope, if, for example, I had put it up here, let's just move it up temporarily, I could also have returned add from getOp. That's a perfectly valid return type for that function. And then when I run this, we're going to get 16, the result of adding 11 and 5. But I'm going to undo that because I think this example is slightly more baffling, and it's always good to tackle the stuff that's a little bit baffling. So in summary, we've seen two slightly different ways of declaring anonymous functions and assigning them to variables. We've seen examples of passing functions to functions, including an example here of literally inventing a function as an actual argument to this runUp function. And we've seen an example here of returning a function from a function. If you're new to all this kind of thing, it's a really good idea to practice this, because soon we're going to look at lambda expressions, which are usually going to be a nicer way to do this kind of thing. And I think they are a lot easier to understand if you are already familiar with the idea of anonymous functions. That's it for this video. Until next time, happy coding.